I want you to think about the last time you tried to quit sugar. Maybe you lasted a day, maybe 3. Maybe you made it a week before something cracked. A bad afternoon at work, a birthday cake, a moment of exhaustion where the only thing that made sense was something sweet. And when you gave in, you probably told yourself you lacked willpower, that you were weak, that other people could do it, but you could not. That story is wrong, and the science proves it. What was happening inside your brain during those days was not a character flaw. It was a withdrawal, a documented, measurable neurochemical withdrawal that activates the same brain circuits as cocaine, heroin, and alcohol. Not similar circuits, the same ones. A 2013 study published in the American Journal of Clinical Nutrition placed sugar in a category of substances capable of triggering addiction-like neurological responses in human subjects. The researchers found that high glycemic foods activated the nucleus accumbens, the brain's primary reward and craving center, more intensely than almost any other stimulus they tested. You were not failing a willpower test. You were going up against one of the most powerful neurochemical systems in the human brain, without knowing what was happening, without a map. Today, I am giving you the map, day by day, because what your brain goes through when you remove sugar is one of the most dramatic and ultimately beneficial transformations in human physiology. If you know what is coming, you can survive it. More than survive it, you can use it. Before we start the clock, you need to understand what sugar is actually doing to your brain on a normal day, because most people think they are eating sugar. They do not realize their brain is being dosed with it. Every time you consume added sugar, sucrose, high fructose corn syrup, glucose, and the 56 other names the food industry uses to hide it, on ingredient labels, your blood glucose spikes rapidly. Your pancreas releases insulin, and simultaneously your brain receives a dopamine surge in the nucleus accumbens that is chemically indistinguishable from the response produced by addictive drugs. Dopamine is the molecule of anticipation and reward. Every time sugar triggers its release, your brain files a memory. Sugar equals survival. Go back to sugar. Over years of repeated exposure, this filing system becomes a deeply grooved neural pathway. The brain does not just want sugar anymore. It has been architecturally reshaped around it. A Princeton University study led by Dr. Bart Hobel demonstrated that rats given intermittent sugar access showed all hallmarks of opioid addiction. When sugar was removed, dopamine dropped below baseline. Not back to normal, into a deficit. That deficit drives craving. And that same mechanism is operating in your brain right now. This is what you are walking into. Not a simple dietary change, a neurochemical reorganization. Day 1. The first 24 hours are driven almost entirely by blood glucose mechanics. When you remove added sugar, your blood glucose no longer spikes and crashes in the rhythmic pattern your brain has adapted to. For the first few hours, you feel fine, normal. This is the window before withdrawal begins in earnest. Then, somewhere between hour 4 and hour 8, the first wave hits. Blood glucose drops toward its lower baseline. Insulin, chronically elevated from habitual sugar intake, is now looking for glucose that is not arriving. Your brain is running on a dopamine baseline that is not yet adjusted. The symptoms are specific. Headache, a dull, persistent ache behind the eyes or across the forehead. This is partly vascular, as sugar withdrawal alters blood vessel dilation, and partly neurochemical, as your brain registers a deficit in the reward signal. Irritability, not general moodiness, but a specific low-threshold irritability, where small frustrations feel disproportionately large. This is your prefrontal cortex operating with reduced support, while the limbic system, the craving-driven region, amplifies its signals. Fatigue. Not the fatigue of physical exertion. The fatigue of a brain that has just been switched to a slower-burning alternative it has not yet learned to use. A 2010 review confirmed that sugar reduction produces withdrawal symptoms, including anxiety, depression-like mood states, and cognitive impairment. Your brain is not just missing calories, it is missing a drug. Day 1 is the hardest day for most people. Get through day 1. Day 2 and day 3. This is the valley. Days 2 and 3 represent the peak of withdrawal symptoms. The headaches may intensify. The cravings become specific and insistent. Your brain is not vaguely wanting something sweet. It is producing vivid, cinematic mental images. A particular chocolate, a specific drink, that one thing from that one place. This is your nucleus accumbens activating memory circuits. The intensity of these cravings is a measure of how deeply the neural pathways were grooved by your previous consumption. Your sleep may deteriorate. Research from Nutrients in 2019 found that removing sugar can temporarily worsen sleep quality before improving it significantly, because insulin pattern shifts alter melatonin timing. Your cognitive performance may feel worse than day one, reaction time slows, working memory feels less sharp. You are in the gap between impairment and recovery. It feels like going backwards. You are not. You are clearing the path. Day 4 and Day 5. Something shifts around Day 4. The headaches begin to lift. The cravings, while still present, feel less urgent, less physical, more like a thought that passes rather than a demand that cannot be ignored. This is your dopamine system beginning to recalibrate. With the repeated artificial spikes removed, your baseline dopamine tone starts to adjust upward. This is one of the most important concepts in this video. When you consume sugar regularly, your dopamine receptors downregulate. They become less sensitive because the signal arrives so frequently. This is the same mechanism that drives tolerance and drug addiction. You need more of the substance to get the same effect. This is why chocolate once felt intense and now feels ordinary. When you remove sugar, the dopamine system begins to upregulate. Receptor density increases. Sensitivity recovers. A 2015 study in PLOS One found that after 2 weeks, participants rated the sweetness intensity of foods significantly higher than before. Their reward circuitry had become more sensitive. Less input producing more response. More pleasure from less stimulation. This is not a metaphor. It is a measurable neurochemical shift that begins in the first week. Day 6 and Day 7. By the end of the first week, the neurological changes are accelerating, and they are no longer limited to the reward system. High-detail 3D highlight of the prefrontal cortex region in a human brain model, glowing with a steady blue light. Scientific. It is the part of your brain that makes you human, rather than purely reactive. And it is the region most damaged by chronic sugar consumption. A 2016 study demonstrated that high sugar intake induces neuroinflammation in the prefrontal cortex, disrupting the signaling pathways that support executive function. Chronic sugar consumption makes it harder to resist craving, harder to make long-term decisions. It impairs the very system you need to stop. It is a trap. By Day 6 and 7, prefrontal function starts to recover. Cravings feel more manageable. Not because you have stronger willpower, because the brain region is functioning more effectively. Energy stabilizes. The roller coaster of glucose spikes and crashes flattens into something more consistent. Your body is increasingly relying on fat oxidation. Your mitochondria are beginning to operate more efficiently. Less oxidative stress, less metabolic noise, more stable output. Day 14. 2 weeks in, the transformation becomes visible in ways that go far beyond how you feel. Inflammation across the central nervous system has dropped measurably. Sugar drives systemic inflammation through multiple pathways. A 2014 study found that reducing sugar intake significantly lowered C-reactive protein and interleukin-6 within 2 weeks. Neuroinflammation is foundational. Your hippocampus, responsible for memory formation and emotional processing, is beginning to recover structural integrity. A 2002 study found that high fructose consumption directly suppressed BDNF, the protein responsible for neuron growth and maintenance. Low BDNF is a marker of depression. 2 weeks of sugar reduction begins to reverse this suppression. Your brain is literally starting to grow again in the region most responsible for learning and memory. Sleep has significantly improved. Deeper sleep stages. More slow-wave sleep, the phase during which the brain performs its most intensive repair. People at this stage consistently report dreaming more vividly, a sign of increased REM sleep duration and improved neurological restoration. Day 30 and beyond. A month without added sugar. The neurological literature at this time point converges on a single word: clarity. Not the vague clarity of a wellness testimonial, the documented clarity of a brain that has recalibrated its dopamine system and reduced neuroinflammation. A 2019 meta-analysis in nutritional neuroscience found statistically significant improvements in processing speed, working memory, and sustained attention in adults who reduced added sugar for 30 days or more. The effect size was comparable to institutionalizing a regular exercise program, not a supplement. The removal of a substance that was impairing function. Ordinary experiences, conversation, sunlight, movement, produce meaningfully stronger reward signals. Your brain has become more alive. At 30 days, the cravings have not disappeared entirely. The neural pathways quiet. They become less dominant. The prefrontal cortex is better equipped, but they remain encoded. Stress, poor sleep, and emotional difficulty can reactivate them. This is not weakness. This is neuroscience. Knowing it means you are prepared. Here is what I want you to carry out of this video. Every time you tried to quit sugar and failed, it was not a personal failure. It was a documented neurochemical process. The headaches, the irritability, the cognitive fog, every single one has a precise biological explanation, and every single one is temporary. Day 1 is withdrawal beginning. Days 2 and 3 are the valley. Day 4 is light. Day 7 is your prefrontal cortex coming back online. Day 14 is inflammation dropping and neurogenesis resuming. Day 30 is a brain that is measurably different. That is not a diet, that is a transformation. Available to anyone willing to understand what is actually happening and stay in the process long enough to reach the other side. What day are you on? Drop it in the comments right now. Subscribe because next week we are going deeper. I will see you there.